Dear students, this class I am going to start another idea in the solutions of the differential equations, that is linear differential equations. First order linear differential equations, how to solve. I hope so everyone know we are discussing all solutions for the first order differential equations only. Here we are going to discuss about first order linear differential equations solutions, how to find out. An equation is of the form dy by dx plus p into y is equals to q, where p comma q are constants or functions in x alone. P comma q are constants or functions in x alone. Observe here, dy by dx, only dy by dx, plus p into y, only y is equals to q. So this is called the first order linear differential equation. P comma q are constants or functions in x only. So this is a linear differential equation. For finding the solution of this linear differential equation, what we are going to do is we will find out the integrating factor. This is the integrating factor. Integrating factor is equal to e power integral p dx. What we are going to do? This integrating factor we are going to multiply both sides of the equation. Then what happens? Observe here. Both sides we are multiplying with integrating factor. E power integral p dx into dy by dx plus p into y into e power integral p dx is equals to q into e power integral p dx. Both sides we multiplied with the integrating factor. Now observe here, what we can write this particular part as. This particular information, this total information can be written as differentiation of, that means d by dx of y into e power integral p dx. Left hand side we can write in this way. Now you can observe, if you apply UV rule, derivative of y, that means dy by dx, UV rule I am applying. This one into differentiation of y plus y into its differentiation. E power x differentiation is e power x into this function differentiation. Integration differentiation cancel, you will get p. So that's why this left hand side we can write in this way, is equals to q into e power integral p dx. Right? So now both sides integrate. Now I can write left hand side as y into integrating factor is equals to integration of q into, this is the integrating factor, into dx. So this is the solution for the given linear differential equation. When a differential equation is in this form, immediately we have to find out the integrating factor. After finding the integrating factor, that integrating factor we are multiplying both sides of the equation. We got this one. Left hand side is nothing but the differentiation of y into e power integral p dx. Now we are integrating both sides. So y into integrating factor is equals to integration of q into integrating factor into dx. So that is the way to approach the solutions for the linear differential equations. Just observe here one question which I am discussing. The question is given like this: dy by dx plus 2 into y is equals to sin x. That is the question given. Very clear. P comma q or constants or function in x alone. Only dy by dx, y alone. It is a linear differential equation. First of all, what we have to find out the integrating factor. Integrating factor is equals to e power integral p dx. Now you know e power 2x, that's integration. You may ask the question, sir, why you are not writing the constant of integration? Yes, we have to write the constant of integration. Okay, I am writing the constant of integration. That means we are writing e to the power of 2x into, that is nothing but e to the power of c or not. So constant of integration also written, but no use of writing the constant of integration. The reason is what we are doing here. Here what we are doing is both sides we are multiplying with integrating factor. Both sides we are multiplying with integrating factor. This side we are multiplying with integrating factor. This side also we are multiplying with integrating factor. In that case what happens? This e power c gets a cancel or not? So that's why while finding the integrating factor, no need to write the constant of integration. Okay, so that's why I am trying to omit that constant of integration. Clear or not? Because this integrating factor we are multiplying both sides. When we are multiplying both sides, e power c gets cancelled. That's why we are writing or not writing, no significance especially. So this is the integrating factor we got. So after getting the integrating factor, this is the general solution. What is the solution we got? The general solution is y into integrating factor, that is e to the power of 2x, is equals to integration of q. Come on, tell me what is the q here. Q is equals to sin x is q into integrating factor dx. Now I can write this one as y into e to the power of 2x. I hope so everyone know the formula for this. This we can write it as e power 2x divided by 2 square plus 1 square into a sin x plus b cos x plus the constant of integration, right? So a sin x minus b cos x. So that is the formula for integration of e to the power of ax into sin bx. That's what I applied directly. So that is the way to approach for the linear differential equations. What we are doing for the linear differential equation? The linear differential equation must be in the form of dy by dx plus p into y is equal to q. Immediately the next step what we have to do? We have to find out the integrating factor. That integrating factor is equals to e power integral p dx. After finding the integrating factor, the general solution is given by y into integrating factor is equals to integration of q into integrating factor into dx. So this is the way to approach for the linear differential equations. Now the another form of the linear differential equation is this one, dx by dy plus p into x is equals to q. This is the another form of the linear differential equation. Observe here, there only y dy by dx, but here only x, but dx by dy. So dx by dy plus p into x is equals to q, where p comma q are constants or functions in y alone. In that case, how to find out the solution for this linear differential equation? Same, we have to find out the integrating factor. Integrating factor is equals to e power integral p dy. General solution is given by x into integrating factor is equals to integration of q into integrating factor into dy. So this is the way of proceeding the second form of the linear differential equations. Now based on these two methods, we are going to find out, or we are going to do few applications. See the first one, x into dy by dx plus 2y is equals to x square into log x. Definitely it is the first form of the linear differential equation. Dy by dx, only y is there. only x is not there. X square is there, log x is also there. So that's why we can convert this one into first form of the linear differential equation. That's why only dy by dx is required. That's why x nikal do. So we'll get dy by dx plus 2 by x into y is equals to x into log x. Come on, tell me, we have to find out the integrating factor. That integrating factor is equals to e power integral 2 by x dx. Now that is nothing but e to the power of 2 into log x. Now that we can write it as e to the power of log of x square. I hope so everyone know a to the power of logarithm of m to the base a, we can write it as m. This is ln, natural logarithm, because base is e here. That's why we can write this one as x square. We got the integrating factor as x square. Now how to find out the general solution? The general solution is y into integrating factor is equals to integration of q into integrating factor into dx. Now you can proceed this one. Y into x square is equals to integration of x cube into log x dx. So this is the first function and this is the second function. We have to apply by part. That's what we are doing. The differential equation means this is just a revision of integration. All the integration ideas we will do here. So now you can proceed this integration. You will get the solution for the given linear differential equation of first order. Another question we are discussing here. The other question is given in this way: 1 plus x square into dy plus 2xy into dx is equals to cot x into dx. That is the given linear differential equation. Okay, I am not saying it is a linear differential equation. First of all, I am showing in the form of a linear differential equation. You can observe here, this is 1 plus x square into dy by dx plus 2xy is equals to cot x. Just by observing the equation, immediately you can say definitely it will come in the first form only, because only y is there. Only y is there, you can observe. Only x is not appearing. That's why here x square is there, x is there, cot of x is there. Only y is there. That's why first form of the linear differential equation. Now again we can write this one as dy by dx plus 2x divided by 1 plus x square is multiplied with y is equals to cot x divided by 1 plus x square. Now we have to find out the integrating factor. Now that integrating factor is equals to e power integral p dx. Now we can write this one as e to the power of log of 1 plus x square. It is natural logarithm, so base is a, so we can write this one as 1 plus x square. Integrating factor we got 1 plus x square. Now general solution is y into integrating factor is equals to integration of q. What is q? Cot x divided by 1 plus x square is q into integrating factor dx. Now 1 plus x square, 1 plus x square cancel. We can further simplification. Y into 1 plus x square is equal to, I hope so everyone know the integration of cot x. Cot x integration is log mod sin x plus the constant of integration. So another question here. The question is given in this way. Integration of, this is x plus y into dy by dx is equals to 1. X plus y into dy by dx is equals to 1. We did this question earlier also when we are discussing the variable separable method. We discussed certain problems reducible into variable separable form. Under that category this question will come. So there we did x plus y is equal to t and then proceeded. But the same question here we are doing by using this linear differential equation. Now I can write this one as dx by dy is equals to x plus y. Sir, here x is there, y is there. Why you are converting in terms of dx by dy only? If you are converting in terms of dy by dx, what happens? You will get this one as 1 by x plus y. 1 by x plus y. No use. We can't convert into the first form of the linear differential equation. Now, very clear. It is in the second form of the linear differential equation. Observe here. Dx by dy plus minus 1 into x is equals to y. This is the second form of the linear differential equation. Dx by dy plus p into x is equal to q, where p comma q are constants or functions in y alone. Now we have to find out the integrating factor. Here integrating factor is equals to e power integral p dy. So we are getting e to the power of minus y. Now the general solution is x into integrating factor is equals to integration of q into integrating factor into dy. Now you can proceed this one. This is first function, this is the second function. You can apply by parts, right? So that is the way of proceeding this type of linear differential equation of second type. Next we have another question. The question is given like this: y dx plus x minus y square into dy is equals to 0. Just by observing the equation, tell me, it is possible to convert into first form? No, it is not possible to convert into first form of the linear differential equation. The reason is y is there, y square is also there, but whether you observed or not, only x term is appearing. That's why convert into dx by dy. Then what happens? Y into dx by dy plus x minus y square is equals to 0. Now the question changes as dx by dy plus 1 by y into x is equals to y. Now it is a linear differential equation of the second type. P, Q or functions in y alone. Now we have to find out the integrating factor. That integrating factor is equals to e power integral p dy. That is equals to e to the power of log y. We can write that one as y. Now the general solution is x into integrating factor is equals to integration of q into integrating factor into dy. Now y square integration, you know, y cube divided by 3. So we can proceed that further simplification. Another question is given like this: dy by dx is equals to y divided by 2y into log y plus y minus x. Come on, tell me. Definitely this is a linear differential equation of second type. The reason is only x is appearing. Y is there, log y is also there. That's why it is not possible to convert into the first form of the linear differential equation. That's why it is a linear differential equation of the second type. Now I can write this one as dx by dy is equals to 2y into log y plus y minus x divided by y. Now further simplification: dx by dy plus 1 by y into x, yes or no, 1 by y into x is equals to 2 times log y plus 1 minus x by y shifted to this side. That's why plus 1 by y into x. Now it is a linear differential equation of the second type. Integrating factor is equals to e power integral p dy. Now I can write this one as e to the power of log y, that is equals to y. Integrating factor we got y. Now the general solution is x into integrating factor is equals to integration of q. What is q? What is q? Q is equals to 2 into log y plus 1 Observe here once again. We got the equation in this form, right? Now y cancel 2 log y plus 1 minus x by y shifted to this side. That's why plus 1 by y into x is equals to 2 log y plus 1. Now its integrating factor is equal to e power integral p dy. 1 by y integration is log y, so we got y, right? So now further simplification we can do it as x into integrating factor is equals to integration of 2 into log y plus 1 into y dy, right? So now you can apply by parts. This can be written as x into y is equals to first function into integration of second function, that is y square by 2 minus, come on, differentiation of first function. This total I am considering as a first function. Differentiation of first function is 2 by y into integration of second function is y square divided by 2 dy. Now you can complete that simplification. So that is the way of proceeding the linear differential equations. So another question we are discussing. The question is given in this way: cos square x into dy by dx minus y into tan 2x is equals to cos x whole to the power of 4, and the information is given as initial value problem. Y of pi by 6 is given as 3 root 3 divided by 8. Y of pi by 6 is given as 3 root 3 divided by 8. He is asking to find the particular solution. That is the reason initial value problem given. That means they will give certain conditions. When x is equal to pi by 6, y value is equal to 3 root 3 divided by 8. That is the meaning. Y of x is equal to this one. Okay, that means when x is equal to pi by 6, the value of y is equal to 3 root 3 by 8. Under this information, we have to find out the particular solution for this differential equation. Very clear, this is a linear differential equation of first form. The reason is only y is appearing. That's why we can write this one as dy by dx plus minus tan 2x divided by cos square x is multiplied with y is equals to cos square x. So that is the linear differential equation we got. Now it is the first form of the linear differential equation. We want to find out the integrating factor. Integrating factor is equals to e power integral minus 2 times tan x divided by 1 minus tan square x into secant square x dx. I hope so everyone followed. Nothing I did. Minus tan 2x formula I applied. Tan 2x formula is 2 tan x by 1 minus tan square x. 1 by cos square x can be written as secant square x. Now you will get an idea how to proceed this further. Denominator differentiation is there in the numerator. Tan square x differentiation 2 tan x, here minus is there, that's why minus 2 tan x into inner function tan x differentiation is secant square x. That's why we are getting e to the power of logarithm of 1 minus tan square x. So that is nothing but 1 minus tan square x. That is the integrating factor we got. Right? So after finding the integrating factor, the general solution is y into integrating factor is equals to integration of q. What is q? Cos square x into integrating factor is 1 minus tan square x dx. Clear? Yes. Now this further simplification, y into 1 minus tan square x is equals to, you will get cos 2x. I hope so everyone followed. The reason is tan square x can be written as sin square x by cos square x. If you take LCM, cos square x minus sin square x by cos square x. Cos square x cancelled. cos square x minus sin square x is the formula from trigonometry, cos 2x. Now what is the integration of cos 2x? 1 minus tan square x into cos 2x integration is sin 2x divided by 2 plus the constant of integration. Now we have to find out the c value, the constant of integration. For finding c value, he has given the condition. What is the condition given? The condition is given as when x is equal to pi by 6, the value of y is equals to 3 root 3 divided by 8. Come on, substitute there. In place of y, we are substituting 3 root 3 divided by 8 into 1 minus tan 30 degrees is equal to 1 by root 3. 1 by root 3 whole square means you will get 1 by 3 is equals to 2 into pi by 6. That means sin 60. Sin 60 is equal to root 3 by 2 into 2, because already 2 is there here. Now this further simplify plus c. We have to find out the c value only. Now this is equal to 3 into root 3 divided by 8 into 2 by 3 is equals to root 3 divided by 4. 3 cancel. Here also root 3 by 4. Root 3 by 4 cancel. We are getting the value of c is equal to 0. So under the initial value problem, under the initial conditions, that is when x is equal to pi by 4 and y is equal to 3 root 3 by 2, we got the value of c is equal to 0. That's why we can write the particular solution as y into 1 minus tan square x is equal to sin x into cos x, because sin 2x is equal to 2 sin x cos x. That's why we got that information. So that is about the linear differential equations, two types, right? So those are two types we discussed. Next class I am going to discuss about Bernoulli's equation, that is extension to the linear differential equation. Okay, bye bye.